Our focus for this video is perpendicular lines. What are perpendicular lines? Two lines are said to be perpendicular if they meet at right angle. That is, the point at which they cross each other, intersect each other, is 90 degrees. And also, if the product of their gradients is equal to -1. Let's just do a quick demonstration of that. Let's say we have a line going in this direction. And we have a next line going in this direction. And at this point at which these two lines intersect each other is 90 degrees. Then these two lines are said to be perpendicular. Let's give them some name. Let's say that this line is P and this line is Q. So we can say that line P, and note that this sign means perpendicular. Line P is perpendicular to line Q. Right? Let's say that this line have a gradient of M1. And let's say that line Q have a gradient of M2. Then M1 times M2 must equal to -1. And those are the conditions that you use to determine if a line is perpendicular or not. They must meet at 90 degrees and the product of their gradients must equal to -1. Let's look at a typical question. Now, a quadrilateral ABCD is formed by joining the points whose coordinates are A, -2, 0, B, 0, 4, C, 7, 3, and D, 3, -5. Show that BD is perpendicular to AC. Now, how is this information over here can help us to show that BD is perpendicular to AC? Now we know that in the question they give us some coordinates for the endpoint of the line. Now we would have known that if a line is perpendicular, then the product of their gradient is equal to -1. That means if we find the gradient of BD and find the gradient of AC, then when we multiply them, and if we get -1, then we make an assumption to say that the lines are perpendicular. So let's go ahead and do that. So let's keep this in mind, that M1 times M2 equal -1. That's if the lines are perpendicular. So using the points, we're talking about BD here, so that means we have to use the point B and the point D. So I have to use those points, B 0, 4 and D 3, -5. Now, if we're using these points, we can say that the gradient of BD, right? In this case, we are going to call the gradient of BD M1. So we can say that M1 is equal to Y2 minus Y1. All of that divided by X2 minus X1. Now remember that we are using these points to determine the gradient. So we know that the first coordinate is X, Y, X, and Y. We know that we need to differentiate between the two X values and the two Y values. So we're going to call this one X1, call this one Y1, call this one X2, call this one Y2. Now in the formula, M1 is equal to Y2 minus Y1. So Y2 here is -5. So it's going to be -5 minus Y1, which is 4. All of that divided by x2 here is 3 minus 0. So simplify this and we get the gradient of m1. So m1 is equal to negative 5 minus 4 give us minus 9. Note here, when the sign are the same, you add and keep the sign. So negative 3 minus 0 is 3. So negative 9 divided by 3, m1 would equal to negative 3. So now that we know the gradient of BD, we need to now go ahead and find the gradient of AC. And the points that we are going to use here is point A and point C. Now, let's call the gradient of AC M2. So we know that M2 is equal to Y2 minus Y1. All of that divided by X2 minus X1. Now, this is X1, Y1. X2, Y2. So now, we just need to substitute these values in this equation. So M2 is equal to Y2. What is Y2? 3. So that is 3 minus Y1. What is Y1? 0. All of that divided by X2. What is X2? 7 here. Minus X1, which is a negative 2. So it is minus 2. Put a bracket. Remember to put your bracket. Simplifying this, so M2 is equal to 3 minus 0 is 3 over negative times negative will give us a positive, or a simple trick. Connect the negative sign and you have one sign which is plus, so this is 7 plus 2 which gives us 9. Now 3 over 9, if you divide both numerator and denominator by 3, then M2 can be reduced to 1 over 3. Now we have both gradients, so we know that the gradient of AC is 1 over 3, and we know that the gradient of BD is negative 3. And we also know that if both lines are perpendicular to each other, when we multiply their gradient, we should get negative 1. So let's see if that is true. So M1 times M2 equal negative 1. So M1, based on our calculation, is negative 3. So this is negative 3 multiplied by M2, which is 1 over 3. Now, when we multiply this, we should get negative 1. So, negative 3 times 1 give us negative 3 over 3 there. And then you reduce this because negative 3 is the same thing as negative 3 over 1 there. And then negative 3 divided by 3 is equal to negative 1. Therefore, we can say that negative 1 is equal to negative 1. So we would have proven that BD is perpendicular to AC. So you would say, therefore, BD is perpendicular. You can use the symbol for perpendicular. Is perpendicular to AC. And that's how you prove if a line is perpendicular to each other.